So hello guys, welcome to this new video tutorial on Python machine learning. So in this video, we are going to go through a very interesting library that I have found recently, that is Gradio, and this library is too awesome to deploy and build a very quick UI for testing out your machine learning applications. So this is the Gradio website, which also appears to be made from Gradio itself. This is their GitHub page and all. So you can check their GitHub page out. They claim build and share delightful machine learning apps very easily, and this is all about it. So they claim that this type of things can be easily made. So I just tried it out, and frankly speaking, I found it really awesome. So let's try to see what can be made from this Gradio. So I have a Jupyter notebook open here, and we have to install Gradio. So we are going to just pip install it. So before everything, just let me try to check if the notebook is on GPU, because we are going to run some deep learning applications also here. So okay, this is fine. So let's try to run this code which they have given and check if Gradio is working or not. So what it says, import Gradio as GR, and then there is a function sketch recognition pass, and then they have called the interface, and in that they have passed some arguments like sketch recognition inputs is a sketchpad, output is a label, and so on. And this is how the actual thing looks like. So you can draw things up here, then you can click on the submit button, you can clear stuff up, and based on the model, then you will get the output here. So this is how this entire Gradio thing looks like. So what we'll do is that we'll try to create a machine learning application and a deep learning application and try to deploy it with Gradio. So you don't need to worry. I have just pre-written the code. We'll go through the code and try to understand what is happening in the code. So firstly, we will try to create a machine learning application. So this is the machine learning application based on the simple iris data set. So we have Gradio, we have Pandas, we have from sklearn linear model logistic regression, and from the sklearn itself we have loaded the data set of iris. So simple, we have just loaded the iris in this, and then we separated the features and the target in different variables. Then from sklearn model selection itself, we have the train test split here. So let me just load it quickly. Then we are splitting the data into a 80-20 split using the train test split method. Okay, then from the logistic regression max iteration, that is 10,000. We are passing the object of logistic regression, creating the object here, and then we'll be fitting it on the data. So we fit it here. Cool. Once the model is ready, then we just need to prepare a function. So this is the predict species function, which takes in four arguments. That is the sepal length, width, petal height, and petal width. So if you are not aware how the data actually looks like, so let me just show you the iris thing, how it looks. So this is how it looks. So since this is a multi-dimensional array, you won't be able to identify it as a data frame very easily. But these are basically the four features, that is sepal length, sepal width, petal width, and they are just in a multi-dimensional array. Cool. So this is the main function which takes the four input sepal length, sepal width, petal width, and then based on the model, it predicts whatever comes in from Gradio, and then it gives out the output. Cool. So we run this thing. Now this is the main part of the Gradio where we need four inputs, right? We want this four inputs from the Gradio, and we will be giving the Gradio input as a slider. That means that it should start from zero, and the maximum slider length should be not length, maximum slider unit should be 10, because petal length I don't think that would be more than 10. So these are the four inputs. Then the output is gr outputs dot text box species. So this is the output box that will be shown on the right hand side. Then simply just call gr dot interface. Then we pass the function as the predict species. This is the function. You just need to pass it. And then the inputs, this is the inputs that you need to pass again, and this is the output that you need to pass, right? All are defined here, and just call the launch method. So let's run this thing. So it gives you some to create a public link, set, share. Okay, it also opens it in a local host. So if you want to open the same thing in a local host, so here is it. It takes some time to load, but it loads quickly. So this is the, let's try to give some features like this. Cool, and try to predict it. So it shows that, okay, this flower is the Virginica flower. And now, again, let's try to manipulate the features again and submit. Still a Virginica flower, right? Let's try to. So it shows now it is a Setosa flower. So pretty cool, right? It was like the UI was ready in just a few seconds. You don't even need to think about HTML, CSS, JavaScript, and make this UI. So instead of that, you can directly make it on Gradio and just showcase it to your higher authorities, and they can take care of the UI part later, right? So this was all about the ML app that I wanted to show. Now let's try to create a deep learning application on a pre-built Cypher 10 dataset where we will be classifying 10 classes. Okay. So if you are not aware about Cypher 10 dataset, just let me show you how the Cypher 10 dataset looks like. So the Cypher 10 dataset is a very famous dataset that has basically 10 classes, and these classes have uh, specific classes like horse, animal, etc., etc., shape and all. So this is a pre-built dataset that we get with Keras. So what we'll do is that we'll create this model using TensorFlow and Keras. We have Gradio again, NumPy for number manipulation, TensorFlow, Keras, and from Keras applications we are using VGG16 to use it as a transfer learning model over the Cypher 10 dataset. Then we load the Cypher 10 dataset here, pass it into two objects, that is xtrain, ytrain, xtest, ytest. So quickly just load it. Then we normalize everything with 255, and the white train is changed to categorical here because the names are in string, right? So we need to change it to categorical first. So once this is done, then we create the model. So the VGG16 model is loaded here. The input shape is defined, weights is from ImageNet, and include top is false. Then we make sure that the last layer, like the last layer is our own layer, because we just want VGG16 over the top of our own layer, own model layers, right? So then we create the sequential model here from Keras where VGG16 object is passed. These are the layers that we define by ourselves. And since we have 10 classes here, the last dense layer will have 10 class, and the activation function is softmax. So we run it, then we compile the model. Since this is a multi-class classifier, so we have to pass the loss as categorical cross entropy. Optimizer, I usually use Adam itself, but I have never tried other optimizer. Just let me know if you have any advantage of using other optimizers rather than Adam in the comment section below. Matrix is accuracy. Then we try to fit the model on 10 epochs, and let's try to see how much time it takes. So here you can see the loss as well as the accuracy. So the accuracy should actually go up and the loss should go down as the number of epochs go on training. Let's wait for some time until the training completes. After that, so again we have to define a function just like the above machine learning application. We defined the function here, also we define the function which takes one input, that is the image that will be uploaded from the Gradio app. It is reshaped into the size which is taken by the model, changed into as type float 32. Then we do the division, that is 255, and then we model dot predict the image on it. The prediction is stored here, right? After that, np.argmax is passed on the prediction, and the class IDX are this. Okay, so the class names are actually this. This has 10 classes: airplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. So based on the class names, whichever is the index, that will be returned back. So the training is now complete. Now the function which was defined, that is also compiled. And then it's time to just create the Gradio output. So simply the inputs, the gr.inputs, and we are passing the image, right? So we have to give the shape also with it, 32 cross 32. Then the output is gr output label top one classes equal to 1, and then simply call the gr interface, pass the function that we defined above, pass the input, pass the output, and launch. So simple, right? The Gradio code the code to launch Gradio is so simple. So we'll just run it, and then it gives you this link. So your application will also be live on this link. but also it will be shown in your collab notebook. So here it you can see, right, it is shown very nicely. If you want, you can just use the local host also. So it gives you the option that drop your image here. So I have some images here. Let me just check that image. So we uploaded a horse image and it was able to predict it was a horse, right? Now I also had one more image. Let me check. So this is the image of a ship. So let's check what's the flag it gives out. Okay, so it was able to identify it as a ship, right? So simple, right? This was like very, very interesting for me to create UI so quickly. No HTML, no CSS, no JavaScript, nothing. Just create a model and then use Gradio to showcase the output to your end user. The accuracy and all is not a matter of concern for this project, but I just wanted to show you about how easy it is to create UI from Gradio. So if you have specific requirements on Gradio, like if you want to create some other application through Gradio, let me know in the comment section below. In the upcoming tutorials, I will try to take that up too. So if this video has added any value to your learning, feel free to like, share, and subscribe. Till then, see you next time.